let's look at question 12, which asks, which of the following series diverge? A lot of people did not show enough work here, so I couldn't really give partial credit. This one, some people treated as geometric. Absolute value of r is sine 2 over pi. Okay, and question was, well, what is sine 2? Well, I know sine is never above 1. So the most is 1 over pi, which is 3.14. So of course it's less than 1. So by geometric, this converges. Okay, if you look at the next thing, this is simply a p series where p is a half. So p is a half, which is less than or equal to 1, so that's divergent. So this one should be a possible choice. This next one gave people problems. It's not really geometric because of that plus 1. The best thing to actually use is the divergence test, where I'll take the limit to infinity, e to the n over e to the n plus 1. If you ignore the plus 1 in this case, the limit is just 1, which is not equal to 0, and that's divergent by the divergence test. So this one also works. Correct answer should have been 2 and 3. The next one had to do with being conditionally convergent. What most people forgot is to be conditionally convergent, you first have to test the absolute value of the series and see if that's divergent. Okay, if the series without the negative 1 to the n plus 1 is divergent, then you can use the alternating series test. Okay, so this series gave people a lot of issues. This is not integrable, so you can't use integral tests. Okay, what a lot of people did, and rightly so, is they compared it with the following series, 1 over n. Okay, this is divergent by p series. Okay, what was not shown for this to be truly divergent is people did not show the fact that this is in fact greater than or equal to, because the ln grows so much slower than this. So technically this series diverges by comparison. Okay, people were not showing that greater than. Once it's divergent, since we know that it's divergent, then we can apply the alternating series test, which says take the limit without the alternating part. Okay, and sure enough, it's 0. It passes the first test. And the second thing, show that the next term, so n plus 1 plus 1, is getting smaller than the previous term. Okay, which in this case you can see works. So this one is what we call conditionally convergent. Okay, but it's only conditionally convergent because first it diverged and then you apply the alternating series test. Okay, the next problem caused a lot of issues because when people were thinking about what happens to the series sigma n over 2 to the n, they were comparing it with this geometric series. Okay, which is fine because we know this is convergent because r is a half. The only problem is the inequality is facing the wrong way. So our airplane is landing because it's convergent by geometric, but our bird is above it, so it's actually inconclusive. But people were saying that it was convergent. So the thing we actually want to do here is apply either ratio or root test. The easiest thing to do, in my opinion, would be root test. So if I take the nth root of n over 2 to the n, that just becomes the limit as n approaches infinity, n to the 1 over n all over 2. Keep in mind that we've worked out in class that this limit to infinity is just 1, so it's 1 over 2, which is less than 1, so it's convergent. And since it's convergent anyway, we say this convergent absolutely. You cannot use the alternating series test anymore, or you do not need to, because we've already addressed the question. The last problem where people had issues had to do with this 2 to the n. So it says use the ratio test. So sure enough, people used the ratio test. They took the limit. It's going to go 2 to the n plus 1, n plus 1 factorial. And here's what threw people off. The bottom is 2 to the n plus 1. Okay? Times, and then the reciprocal of the original. 2n factorial over 2 to the n, n factorial. Okay? What I want to bring up is this point right here. Okay, this jobby is 2 to the n plus 2 factorial. And in order to cancel with the 2 to the n factorial, keep in mind this is really 2 to the n plus 2, and then you're counting down 2 to the n plus 1. And then 2 to the, or not 2 to the n, 2n plus 1, 2n factorial. So this is the point where you can start canceling this. Okay? And people were sharp enough to catch that this canceled, and then the to the n canceled. Okay, so it turns out that the limit when you work it out is actually 0, which is convergent, because it's less than 1.